Okay, so Dr. Stevens does a lot with using the Z-score formula, and that certainly works well. I often will do it that way myself, but many times you folks have a hard time with the formula, crunching the numbers. So I'm going to show you how to use this David Lane applet. I really like what he does. Now, sometimes it doesn't give us enough decimal places, and for the computer homework problems, we might have to use a different applet, but this one will certainly be a great starting place. So we're working with this. So these are problems from the book textbook, and these are all on the standard normal curve. And I know it's on the standard normal curve because they're just telling me a z-score already. I don't have to calculate a z-score. So I'm going to do a couple of things. Well, like for question number A, on this curve, I know on the standard normal curve, the mean is 0, the standard deviation is 1, because these are the number of standard deviations away from the mean, right? They want me to go less than 1.96. Well, I'm going to select, I've got the mean 0, the standard deviation is 1. Then I'm going to go below 1.96. And as you can see, there's the answer right there. All right, so almost 98% of this distribution will be less than a z-score of 1.96. Greater than or equal. Now, here's the tricky thing about this. Maybe it'd be good to watch this. Tell it. I'll record a separate video for this. Why there's no difference between less than or greater than. That way, that'll keep this video shorter. If I want to go greater than, I'm just going to go above, and I'm going to type in the 2.13. I don't have to change the mean because this is the standard normal curve, and that's the answer, 1.066. And we're going to ignore that equal to sign for a minute, because I'm going to explain why we can ignore it. Question part 3 would be in between, so we're going to click between negative 1.21 and 2.13, and then it shows me the nice shaded area. That's one thing this applet's very nice about, showing the sketch. I always do a sketch when I'm working with normal curves. That way I know what I'm talking about. What if they ask me outside of, for question number 3, what if they ask me for outside of that range? Well, what you do is you do outside. So actually I got to change my numbers. Negative 1.2 1. Why did I have 9.6? I guess I mistyped that. Let me fix that. Change it slightly. And 2.13. And if I go outside that, I'm looking for those white tail areas. So notice how it just switches it. And what it did is it took this number, this answer, and subtracted it from 1. It probably did a little bit more than that mathematically, but that's the net result. Okay, so that's how you use this David Lane applet in order to calculate a probability from a value. And then for question number 2, it says, hey, we've got some z-score that has an area of less than that of equal to 0.85. So what we're going to do with this applet, you're going to select value from an area, and the mean is still 0, the standard deviation is 1, and they're telling me, hey, you've got this area, what z-score cuts that area off? So I'm going to type in 0.85 as my area, and actually that's above. I want to go below, because this says this one says below. Part A says below, which is that z-score, and so that would be the answer for the first part of this. Well, I guess it's not. He's making you work through this, isn't it? But that is the z-score that cuts that off. Why is this greater than, or why is greater than that value 0.15? Why is that white area over here 0.15? Well, it's just 1 minus the 0.85. The complement. Is the z-score positive or negative? I knew this was going to be positive because this area is bigger than 0.5. Z-score 0 cuts the normal distribution in half, with 0.5 less than that, 0.5 greater than that. So we answered that. So suppose you go, what's the value that goes in between those? So now they're looking for, what are they doing here? I'm thinking what they're asking us to find is find the two z-scores that cuts off the middle 85%. Or no. They're telling us what's the 85. So I've got a z-score positive 1.036. What's the area between negative 1.036, negative 1.036, and positive 1.036? So now we're back to value from an area. I'm going to go between negative 1.036 and positive 1.036. So that would cut off almost 70%. And that would make sense because this is 15, this tail area is 15% or 0.15, and this tail area is 0.15. I'm rounding because it's not exactly. Does that make sense? Okay, so that's how you use this applet to find a z-score when you know the area.